Hello friends, good evening all of you. So today's session we are going to cover fixed point and floating point representation in Unit 2 computer system architecture. Okay, let's move on to the topic now. First one, what is fixed point and what is floating point actually? So actually for to store the real numbers we need actually two types we have actually, that is called fixed point and floating point representation. First one, what is fixed point representation? So this is actually stores numbers with decimal binary points at a fixed position. So the number of bits allocated, for example, 8 bits means after decimal point, that's a bit. 4 bit means the 4 bit. So the number of bits allocated for the integer part and fractional part remains constant. It won't change. That is called fixed point representation. So you can see a format, integer part, fractional part. For example, here, 8-bit format I am taking. So 8-bit format means what actually? See, this is 10101100. This is 8-bit format. So first one, this is called integer bit. And second one, it's called fraction bit. So how many they are saying that is like that? It has to divide integer and fractional part. For example, binary numbers just 1010.1100. This is actually binary number. What is the integer part and fractional part? We have to find out the decimal part for this one. Now you can check, this is called what? 2 power 0. This is 2 power 1. This is 2 power 2. This is 2 power 3. So this is 2 power 1. Just you can calculate 1 into 2 power 3. And which one is there? Plus this 1 into 2 power 1. That's all, it's enough. Then plus here 2 power minus 1, this one, and 2 power minus 2, and this is 2 power minus 3 and 2 power minus 4. Actually we saw the last class the conversion concept. Actually the conversion concept full and full we have we have discussed about not decimal point. So normal numbers just we have discussed about, without decimal point we have discussed. Suppose if we'll take a decimal point, this is the concept actually. We have to work out like this. Now just 1 into what? 1 into 1 by 2 power 1 by 2. 2 power minus 1, what is the meaning? 1 by 2. Yes. So okay. Plus 1 by 2 power minus 2. That is called 4. Yes. So anyway 0, everything is 0 only. So no need to work out zeros. It will take time actually. Writing time and calculation time, it's everything, it's a waste actually. So if 0 is there means you can do multiplication 0 only. Now you can take 8 plus, this is 2. This is after decimal point, this one. Here, what is 1 by 2? 0.5. And what is 1 by 4? 0.25. Yes. Now my decimal point actually 10.10 point. This is called 75. So this is my actually my value for this one binary number. This one for I got decimal numbers 10.75. This is the answer. Okay, just we can say another example. Now 5.625. So this 5.625, they have given fixed point representation. This I have to convert 4 integer bits and 4 fractional bits. For first one I have to convert as a binary. Then I have to convert as a 4 integer and 4 fractional. First one 5, how you are going to convert? 5 division, just you can do division method. So 2 2s are this one, and 2 1 2s are, this is actually what? 0. So this is bottom to top. Yes. So 101 I got. 101. Okay. So here before decimal point 4 integer bits are. So I will take 0 ones before this one. So point. Now 6 to 5 we can calculate. How we are going to calculate means for pointing value, just you can take 6 to 5 into 2. What is the value? 1.25. 6 to 5 into 2, how much? Just 10 versus 5. 6 into 2, 12. So 1.250. Now what I have to do? Just 250 you can put here. Okay. So remaining you have to put, this is just value this one you can put here 1. again I'll tell you 1.250 means pointing values we have to put work for this calculation again, and 1 for just we have to put as the remainder value. Okay, like this. Now this 250 I have to take into 2, we have to multiply. So what will happen? 0.500. So this 0 we have to write here. This 500 again we have to write here. 500 into 2 equal to 1.00. How long it has to come? 1.00. Now this one you have to write here. Anyway, after calculating 0 only. So this one we have to take top to bottom. So 101, 101. So here also we have 3 values. So I can take right side 10. So my value will be 0101.1010. That is called actually binary. If you know binary terms, actually octal table, this table just we can understand this while seeing this one. We can say this is 100101. This is called 5. Yes. Okay. Now, next one, just one more example we can see. For example, minus value. For example, I will take minus 7.5. This is 10. So now I have to take 4-digit bit and 4 fractional bit. 4-digit integer bit, 4 fractional bit. So what I have to first actually, first one I have to take 7 for binary. So 7 binary what? Just you can take 7 binary just division method. So 3s are, this is 1 and 2 for 1s are 1. So 1, 1, 1. Okay. Now we have 4, sorry. So now 1 we have to put 3, 1, 3 values are there. So we have to put 0. So over. This is 7 we have found. 0.5. What is 0.5 value? So what is the 0.5? 0.5 last class we have completed. 0.5 into 2. This is called 1.0. So I will get 1 here. This 0 nothing will value. It won't repeat actually. So 1 means top to bottom. So I got here 1 only. So automatically what will happen? I have to put 0, 0, 0 right side. So my value will be 0.1000. This is okay. Now we have to take minus they have given. Minus means what I have to do? We have to take 2's complement. First I am taking 1's complement. 1's complement means what? That is called negation of the opposite numbers. The numbers negation we have to take. So this is 1. This is for 0. This is for 0. This is for 0. Point. This is for 0. This is 1, 1, 1. 2's complement means we have to add it 1 here. So 1 plus 1 0, 1 plus 1 0, 1 plus 1 0. Here 1 carry 1 is there, no, this carry 1. So 0 0 0 1. So this is my number for 7 minus 7.5. My number will be, this is my 1000.1000. Okay, this is for binary number. Like this we need to calculate for fixed point representation. Now we are going to move the floating point representation. Next one. Okay. So for before that, just we'll see what is the advantages. Simple implementation, fast arithmetic operations. It's fixed point only, no problem here, less memory required. So disadvantages: limited range, lower precision for very small and very large numbers. And applications where we will use means embedded systems, digital signal processing, microcontrollers, and financial calculations. Now we can see it's a floating point representation. So what is a floating point representation means? Actually it stored numbers in scientific notation, allowing the decimal point to float. So it is used to represent very large and very small numbers. Here infinite. So very large numbers also we can use it. Actually general format, actually sign, exponent and mantissa. Okay, sign, exponent or mantissa, this format just we can use for this one. It will be very good. Okay, so it has actually 3 parts: what? Mantissa, exponent, base, exponent. So like this we can write actually plus or minus m into b power e, base power exponent. Like this we can use actually. For example, we can see, just I'll write here. Before that, I'll write number. This is called Mantissa. This is base. This is exponent. Just you can take for example 110, 111 into 2 power 9 means, what is Mantissa means 111 is Mantissa. Base value that is called 2. Exponent value this is called 9. So like this we have to write. Okay. Okay. Now we can see the samples for program. Sample question, represent 45 dot float was a 0.5. So we have to convert the binary. 45, what is the answer? We have to practice everything. 45 we have to use divide model. 2s are 1 and 2s are, this is 1, 1s are 0 remaining, and 2 just you can take 5s are remaining 1, and 2s are means 2, this is 1 remaining 1, 2s are means 1 remaining 0. So bottom to top we have to take, so 101101. So 101101. This is called 45. We know already 0.5. What is the answer? Just 1. Yes, last class, last slides we saw. So 0.1. So my answer will be 101101.1. That we have to normalize. Move the binary point after the first one. This is when we have to move the first place up. So 1.011 here, 1.011 Okay, so this point we have to move first place up. Okay, how many places? 0, 1, 2, 3, 4, 5. So 2 power 5 it has to come. So that is normalization, that's all. So here sign 0 plus 0, this means positive. Exponent of what? This is called 5 exponent. Mantissa what? 0, 1, 1, 0, 1, 1. That is my Mantissa. So what is the 45.5 value? This is called 1.011011 into 2 power 5. What actually this format actually? Plus or minus m into b power e, this format I have written, that's all. Okay, so next question we will see actually some other question. For example, I'll write this page. For example, 1259.125 just I can take. So here how we are going to calculate that fixed floating point representation. Okay, so here we are going to calculate single precision and double precision format also. First step 1, convert the decimal to binary. So first one, 1259, what is the decimal point we have to convert? So 1259, what is the decimal point? So 2 we have to divide. So 6 or 2s are, and this is 9s of 1. So here 2 means like this we have to divide. Just we will get answer actually. So what will get answer means 100 1110011. This is actual answer. If we'll do the calculation, for example, here 3s are 1 and 4s are just 1, and just again you can do 1s are and 5 and 7s are 0, and like this we can do. For last one you'll get answer actually. Okay, 0.125, 0.125, what is the answer we will get? So that we have to do, we can do now. 0.125 into 2, what is the answer we will get? 0.250, yes. 0.250. So now 0, this 0 we have to take here. This 250 we have to take here, yes. So into 2, now this 0.500. Now this 0 we have to keep it here, and this 500 we have to take up to 1, it has to calculate. Yes, we know that. So 2 equal to 1.000. So this one we have to take here, that's all. Wow, close, because 0 only, nothing will happen. So top to bottom it has to take. So what is the value for me? Is this 001 will value. So my answer will be actually 100 1110011.001. This is my binary format for 1259.125. Okay, that we have to normalize the number. So what we have to do, we have to normalize. So normalize means what? We have to take that point value, we have to keep it in the first place. Now what will happen? So here 1 point, this 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1. Here this 0 1 also it will come here because the point it will go we have written here. So 0 0 1. So how many place? 1 2 3 4 5 6 7 8 9 10. So into 2 power 10. So now what happened? M into b power e calculation. Mantissa into b power base power exponent format we have written now. Now first one, single precision. Single precision, just we can write, this is called single precision. Single precision, actually formula actually 1 point n e power, the sorry 2 power e minus 127 equal to, you can write 1.00111100 1 into 2 power 10. This is the meaning. Yes. Now this point you can see 1 point n. This is 2 power. The same thing here we have. Once again, the same thing here also we have. Now we have to take that power value only. So e minus 127 equal to this what 10 now. So 10 I am taking. So e equal to 137. Just I am going to erase this one. It will be easy to work out. Just a single precision we can do here. Double precision again we have to do some other place. Okay. Okay, now this 137 we have to calculate as a what is a 137 binary format. 137 binary format we have to divide again this format. So what is the answer we will get? Actually 137 means 1 triple zero triple zero 1001. Okay, this is the exponent format. So this is a single precision format. I'll write here. So first one 1 bit. This is 8 bits actually exponents, and Mantissa actually 23 bits. Okay, 1 bit, this is called 0. Exponent you can write the same exponent 8 bits. 8 bits sure you will get 8 bits. 1 0 0 1 0 0 1. And Mantissa, you know that this Mantissa full and full you'll write. So how many values are that? 0 0 1 1 1 0 0 0 1 1 0 0 1 and dot 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 0 0 0 will get up to 23 bits. That is called actually single precision format. The same thing double precision format also we will see, because they will ask anything single precision or double precision. Double precision format. Okay, so here 1 dot n, the 2 power e minus 1023 equal to the same thing. I'm going to write 1 0 0 0 1 1 0 0 0 1 1 0 0 1 into 2 power what 10. So we have to take this exponents only. So e minus 1023 equal to 10. So e is equal to 1024. So 1024, what is the exponents format means? Just we have to uh, calculate, divide by calculate. This we can do that. Reminders we have to take up. Equal to, what is the answer we will get? Actually 11 bits we will get. 1 0 0 0 0 0 and 1 0 0 1. Even you can take this one. This is 2 power 0, 2 power 1, 2, 3, 2 power 1. This is called 2 power 1, 1. 2 power 3 called 8. 4, 5, 6, 7, 8, 9, 10. That is called 1020, this one. So like this, we will have to calculate. That also we can do. Okay. Now just you can see to it. Okay. So now just we can write in the double precision format. Here actually 1 bit. Here actually 11 bits. Here actually 52 bits. This is called the double precision format. This is 0 to 51. This is 51 to 2 to 62 and 63. So here 0 exponent this value we will get here 1 0 0 0 0 0 0 1 0 0 1. This is exponent. Mantissa what will come? 0 0 1 1 1 0 0 0 1 1 0 0 1. After that you can write 0 0 0 0 like this 52 bits. This is called double precision format. So actually many times they will ask you simple questions. They will ask you what is the exponent bit for this double precision format. Simply they will give this formula, we have to write and we have to, they won't ask in full and full like this format. They will ask questions double precision floating point representation. They are directly they will ask how many things we have to follow mantissa, like this, that steps they will ask you. And formula they will ask what is a single precision format formula and double precision format formula. And they will ask about, they will give fixed point or floating point representation numbers, and they will ask us to work out. And sometimes they will give sums, and we need to find out only exponent value for single or double precision. So like this questions will occur. Kindly see to it. It's a very important questions for single precision, fixed point and floating point representation. So before that complement also we have to know ones complement, twos complement I have taken already in some of the problems here. Maybe subtraction, and nines and tens complement also we have to know. Okay, so next classes we are going to see it's still other concept, it's a very important concept about COE. Okay, so thank you all of you. Thank you once again. Just you can go through every videos. If you have any doubts, you can ask in the comment section. Thank you all of you.